Okay. Let me prepare my material. Okay. So let's start. Hello. Welcome back. Hope you're doing great. Today we'll study fluid mechanics. Ito, paalala lang, medyo mahirap to or it might be a lot to take in again. So yes, we'll just after this, we'll look at problems from your textbook na gagamitin nyo. Tapos try lang natin ng itry. No? Okay. So let's start. What's a fluid? Of course, what's a fluid? We're studying fluids. What's a fluid? Basically, a fluid is anything that flows. It can flow, follow the shape, or change the shape of the volume that it occupies. So, liquids and gases siya, no? Naiinom ba natin siya? Nakakalipad ba tayo doon sa fluid na yun? Nakaka-swimming ba tayo? Pag, pag nagagawa natin yun, fluid yun. Okay? Ang gases is fluid. You might be surprised. No? You might be surprised. Next. Today, we're going to be using the property called density a lot. So, I know what you know. I know you know this na. Density is an important property of any material. Kasi maraming physics properties, chemical properties nagdidepend dahil sa density. It is defined as the mass per unit volume. So, it's constant for every substance. Intensive property, meaning kahit ganong kalaki man or kaliit tong pencil ko, yun pa rin yung density niya. It is rho equals mass over volume. May mga common densities tayo. Okay lang, mamaya babalikan natin to. So, don't worry. Na lang, just to show you. What are what's available? What's available? SI units is kilogram per meter cube, hindi gram per cubic centimeters. Okay. I'm sure kayang-kaya nyo to. Sige nga, 1 minute. Can you tell me the answer? 2 minutes pala. Para lang sure tayo if you know the concept. Check natin. Okay. Okay lang naman. Okay. Sige, that's enough. That's 2 minutes. Tama kayo. So, syempre, una natin gagawin is to get the volume. Length times width times height is 60 cubic meters. So, we just compute. Mass and weight. Paano ulit kunin yung weight? Mass times gravity, mg. No? So, weight, wala lang, baka lang interested kayo. Weight equals rho vg. Ito, this one is mass. This one is g, acceleration due to gravity. So we just do accordingly. For air, rho v equals to mass equals 72 kg. Weight equals to mg equals to 700 newtons. For water, ang dali lang yan. So water is rho v. So bigat ang water, of course, kasi mas mataas density niya, mas dense siya. Weight equals 5.9 times 10 to the 5th newtons. All right? That's easy. So now let's go on. Move on na agad tayo. Pressure in a fluid. Fluid pressure. So in fluids, guys, 'di ba may tubig kayo? Teka, kuha ako ng tubig para mas makita niyo. Nakika-out ako. Wait lang. Okay. So a fluid exerts a force perpendicular to any surface it's contact with. Just as the regular physics, no? May normal force. Meron din siya weight, no? So, normal force parati. Diba? Di ba? But hindi gumagalaw yung tubig pag nasa glass? Kasi on rest siya. Pero paano mangyayari yun? The fluid must exert forces of equal magnitude but opposite direction on the surfaces. Two sides. No? Or sige, mas magandang analogy siguro, pag nilagay ko yung baso nandito sa picture ko, mas maganda siguro yung ano yun. 'Di ba? Meron kang flat surface. So para maging at rest yung surface, tsaka yung fluid, dapat walang net force. So dapat kung ano man lahat ng forces nag-interact sa fluid ay sa surface na yon, equal sila, equal in magnitude. Yan, that's the definition of pressure actually. Yan, this is a good illustration. So, simply, fluid pressure is defined as the force exerted by the fluid over an area. So, there are lots of if may surface kang ganyan, no? By the way, dahil grade 11 na kayo, pag grade 12 na kayo, I will use a lot more calculus stuff. Kahit di ko pa kayo natuturuan ng calculus, but I'm sure you have an idea. Yan na, may mga elements na differential and stuff. That's how physics works kasi talaga. So, just as a warning. Okay? So, what's next? Force exerted by fluid over area. So, if we take small elements, ayan. No? Tas iba-iba yung pressure at each point. Ayan. At a point in the fluid. So, to get the total, i-integrate natin yan. Pero, hindi pa kayo physics 4, so hindi niyo pa alam yan. Pero, dahil we are dealing with basic cases, if the pressure is the same at all finite points, uniform, force perpendicular, take note force perpendicular or net normal force, no? Net normal force perpendicular to the area over the area of that surface. And the SI unit is Pascal. Next surface. Next topic. Atmospheric pressure. It is defined as the pressure exerted by the Earth's atmosphere. No? So basically, ito yung definition. Ito yung definition. Do you see this? Bale, you take an area of 1 square inch. No, 1 square inch. Tapos, kunin mo yung force na ini-exert from the top of the atmosphere. 180 m is defined as that. Kung gaano karaming force yan. Remember all of this? I'm sure na-discuss nyo na to dati. Grade 7 siguro. I'm sure na-discuss nyo to. Okay. Yan, yun yung pressure na ine-exert ng Earth's atmosphere. Nagbabago siya depending sa height. Nagbabago siya depending on where we live. Pero at sea level, ito yung ginagamit. Okay. Next. Nakakuha ba? Ayos ba? Okay ba? Before we continue. I hope you get the concepts. Do you get it? Okay naman ba? Okay. I hope okay naman. Sige. Unang nag-chat. Okay. Sige. Also, remember, baka malito kayo on the definition of force and pressure. They are maybe the same, pero ang pressure, not a vector, yan vector. And it acts perpendicular to a surface. Parate. Force is a vector with definite direction. Also, yung force, hindi siya pressure. Kasi ang pressure, force per unit area. Mas mataas yung level niya ng konti. Okay? Yun. Let's go to the next part. Ito, mag-derive ako ng konti. Para lang, kasi useful yung way of thinking niya to approaching the problems. Okay. So, handa kayo guys? Okay. So, ito. Let's examine, kasi yung pressure, pansin nyo ba kapag nag-swimming kayo, di ba? Parang mas the deeper you get, mas malakas yung pressure. Or kaya simple lang, pag nag-swimming kayo, mas matindi yung pressure sa baba kaysa sa likod, di ba? If you hear that, it's because of this. Pressure depends on depth. Bakit? Okay, let's see. So, if the weight of the fluid can be ignored, yung pressure is the same throughout its volume. The pressure in a fluid is the same throughout its volume. No? We can derive a relationship between the pressure at any point in a fluid at rest and the elevation of y. The point. No? So, bali, we can derive a relationship between the pressure here and here. No? Okay. So, para okay tayo, assume na fluid is in equilibrium. Next, density of the fluid is constant. G is constant. Okay? Tapos, we get a small element. So, paano ba tanggalin yung... Sorry guys, Teka. Gagana ba yan? Do not disturb. Yan siguro. Yan. Okay. Okay, sorry. So, kukuha tayo ng sobrang liit na part. So, para bang kukuha tayo ng box sa loob ng fluid. Hindi ko to ma-explain ng buti sa inyo. You'll know more about this sa grade 12. Pero kasi dinidiscuss to sa physics. So, So, kuha tayo nito. So, let's say that ang thickness niyan of that element is dy. No? And yung top and bottom elements, ito y, ito y plus dy. So, ano yung volume ng fluid na to? Any guess? Madali lang. Dahil small element lang yung kinukuha natin, so, dapat small, lang. Bali, area times the height, di ba? That's how you get the volume of a box. Actually, hindi lang box. Basta kahit circle siya, area times height, di ba? Area of the base times height. Tapos yung mass niya, di ba ang mass is rho v. So ang small mass is rho dv equals rho a dy. Next. Ang change in weight, small change in weight is mass times gravity. So small change in mass times gravity. What's next? Na in rest yung thing. So, mute ko nga lang to. Pati ako nalilito eh. Yan. Okay. Sorry for that. So, ano na yung important na i-consider na forces? Now, let's look at all the forces acting on this thing. Let's use this as a figure of reference. Diba, isamin natin, for simplicity, let's say it's a box. So, the fluid exerts forces on all four parts of this one. The forces on the four sides of the element cancel. Pero yung taas tsaka yung baba, hindi. Kasi, meron kang difference in height eh. O kasi wala. No? If you think about it. So, what's next? Let's add the forces. Free body diagram. Diba pataas yung PA, pababa yung mas taas. Tsaka may weight pa. So sure kang magkaiba yung forces na acting. Magkaiba yung force na to tsaka ito. No? Ano pala yun? What's that? PA, diba? Ang force is pressure times area. Pressure equals force over area. Force equals pressure times area. Kasi ito, bakit by dP? Kasi dahil sa small change of this one, yung dy, nagkaroon ng small change in pressure also. Alright? Yun. Let's examine the y component. PA upwards minus P plus dP times A minus d weight equals 0. Rearranging, we get that dP over dy equals negative rho g. Yun na, tapos na. So, it shows na when y increases, P decreases. That is, as we move upward in the fluid, pressure decreases as we expect. No? Oo. Kaya kapag the deeper you go, mas masakit mag-swimming, di ba? Then, by calculus, Kapag in-integrate mo yan from two pressures, dP equals negative rho g dy. Pag in-integrate mo yan from P1, P2, Y1, Y2, pressure difference between two different points in a fluid of uniform density. Pag integrate mo yan, ito lalabas. So please take note of this. Important yan. And another way to rewrite this is the yung parang is to how to say, is to write it in terms of depth. So for parang mas madali, it's always nice na parang if you're gonna apply this in physics, no, always good na yung isang point mo is yung top ng fluid. Wala lang, for convenience. So gagawin natin siyang P naught minus P1, which is ito. Final minus initial. Final minus initial. Okay. Kaya natin yung pressure difference between point 1 and point 2. So, P2 minus P1. Set this as P2, set that as P1. So, itong Y2 minus Y1, diba? Y2 is, ito yung origin. So, we subtract. Ito yung makakuha natin. P negative rho GH. This is a very familiar formula to you, I'm sure. Pressure at depth H in a fluid of uniform density is the pressure at the surface of the liquid plus the depth below the surface. Yun. No? Yun. Basically, your height is defined from the surface. From this point hanggang dito. I hope you understand. Before I continue, naintindihan ba yung ginawa ko? Pag-isig, okay ba? Anyway, ito yung important. The formula. Don't mind about the calculus I did. So yes, ito no. Ito siya. Before I move on, you get it? I need assurance. Ano, kamusta? Naintindihan ba? We'll do examples later. Okay. Sige. Walang Okay. Do you get it? Dali, last question. Before I move on. If walang sumagot sa akin, hindi gets nyo to. Okay. Sige, let's go. Pascal's law. Pressure applied to an enclosed fluid is transmitted and diminished to every portion of the fluid in the walls of the vessels. Medyo gets. Okay lang. Mamaya, ayun, buti yan. Kahit medyo gets lang. Okay na sa akin yun. Kahit ganun lang yung marinig ko. Please, kasi sayang yung pagsasalita minsan, no? Mamaya naman we'll have examples. Yun na yung gusto ko marinig. Medyo gets. Okay, thank you for answering, Megan. Okay, next. Pascal's law. Applied to an enclosed fluid is transmitted and diminished to every portion of the fluid in the walls of the containing vessel. So, if mag-apply ako ng force dito, dyan, lahat yan pare-pareho ng pressure. No? Pero, pareho yung pressure, pero magkaiba yung force na ini-exert depending sa area. Basta pareho yung pressure. Basta pareho yung pressure, no? Kaya rin sila pareho ng height. Bakit? Kasi at the surface, P equals P naught plus rho GH for everything. Dahil na dahil important na pare-pareho yung volume, ay pare-pareho yung pressure, so dapat pare-pareho yung height, no? Pare-pareho yung surface temperature, ay pressure, kasi lahat sila naka-expose sa atmosphere, and dito na rin nagkakatalo sa PGH, sa rho GH. So, dapat magkapareho sila ng height to satisfy this. Kaya, ayan, di ba? Hmm. Kaya dapat pareho sila ng height. Next, Pascal's law. Ito pa yung isang application. Nakikita niyo yata ito sa pag nag-aayos ng kotse. No? Pareho yung pressure. No? Pareho yung pressure at all points in the fluid. So, kahit magkaiba sila ng force, as long as inaiba yung may area, the changes would happen. So, dapat same pressure. Pressure dito is the same as pressure dyan. PA1 equals PA2. Kaya F1 over A1 equals F2 over A2. Therefore, you can get a relationship between the forces of a hydraulic lift. Okay? Last point for this topic. Absolute and gauge pressure. Absolute pressure is a total pressure exerted on a fluid. Ito yung ginagawa natin. Gauge pressure, tatanggalin natin yung atmospheric pressure. Itong P0, most of the time, atmospheric surface pressure yan. No? Yun yung 1 atm. Yun yung 1 atm. So, gauge pressure, tatanggalin natin. Ngayon, I want you guys to try these. Ito muna, yung pinakauna. Water stands, yan. Pakitry. Okay. Sige. Baka nakakalito pa rin yung concept, so sige ako muna. Okay. Water stands 12 meters deep in a storage tank whose top is open to the atmosphere. What are the absolute and gauge pressures at the bottom of the tank? Okay, ito muna tanong ko sa inyo. At the top of the tank, ano yung pressure? Ano yung absolute pressure? Sige, isipin nyo ito. P, rho naught plus rho GH. Ay, mali. P naught plus rho GH. So, at the top, absolute pressure is, dahil zero yung height, hindi siya bababa eh. Nasa taas lang siya. P naught. 1 atmosphere. Ngayon, tatanungin ko kayo, ano yung gauge pressure? Ano yung gauge pressure at the top of the surface? P minus P naught. Diba? P minus P naught equals rho GH. So actually, kahit rho GH lang kunin natin. Ang gauge pressure is 0. Ngayon, how about this one? At the bottom of the tank naman, nuloko yung pencil. Yan, di ba? Yan. No? H equals 12. So, 1 atm plus 100, ano yung density ng water? 1,000 kilograms per meter cube times 9.8 times 12. Ang 1 atm is 1.01 times 10 to the 5th PA. Para? Let's just use Pascal first. Teka lang ha. Times. Naayos ko yung sulat para okay lang. 2.19 times 10 to the 5th PA equals, convert to atmosphere. Di ba ang atmosphere is 1.01325 pascals, no? 2.16 atmosphere. Ang gauge pressure, P minus P naught. So, simply, ito na yung P, di ba? So, subtract lang tayo ng 1 atm. Okay. Nagets yung difference ng gauge pressure tsaka absolute pressure. Pansin nyo, mas inaanak ko ngayon kaysa kanina. Wala lang, para lang hindi kayo malito. You get it? Yes, no. Difference between gauge and absolute pressure. Okay, sige, that's good. Ito kaya, paano sagutan to? Okay, ito, dito magagamit yung Pascal's law. Bakit? Yung pressure dito, exerted by the atmosphere here is also the same as the pressure exerted by the atmosphere here. Right? So, or in other words, yung pressure, kung saan sila nag-contact, pareho rin. Kasi in-rest yung fluid eh. Equal yung force na in-exert nila sa bawat isa, dapat equal yung pressure nila sa bawat isa. Hindi siya gumagalaw by Pascal's law, kaya pare-pareho. So, what can we do? Use natin yung P naught equals rho GH. So, sa water, yan. Yun yung importante. Water equals P naught plus rho water GH water. For oil, plus P oil GH oil. Tapos, kung natin yung height ng oil. Kasi, ano lang, solve the equation. Solve the equation. Basically, pag sinolve natin yung system, pasensya na, no? Medyo matagal na rin kasi ako hindi ginagawa to. Kaya, medyo bagal din ako. Yeah, I'm reviewing na rin para sa next semester ko. At least ngayon, alam ko na kung paano. So, we get the relationship. Ayan. Okay. Before we continue, do you understand? This is how you use Pascal's law. Ang tawag pala dito, manometer, yun yung pang measure na pressure. No? Yun yung pang measure na pressure. So, yes. Okay. So, do you get this item before I move on? Kasi next topic na agad. Do you get this, ano? Do you get this item? Or do you want me to explain again? Okay, thanks for saying. Pwede rin kayo mag-unmute para sabihin. Wala lang. Nakakalungkot na ako mag-isip. Anyway, we can continue. So now, Archimedes principle. Kilala niyo naman siguro si Archimedes, no? Siya yung nag-measure ng siya yung matalinong nag-discover kung ano yung totoong density ng gold. Parang ganun yata. Like, may dalawang crown, tas yung isa fake, yung isa totoo. He used this principle to like help him. Ito yung Eureka eh. Siya yung nagsabi niyan eh. Archimedes. Tama ba? Search ko nga. Para lang sure tayo. Eureka, who said? Oh, yun, di ba? Oh, ayun. Eureka. Si Archimedes yung nagsabi na. Yung storya nun, dahil sa buoyancy. Okay. So, ito guys. So, the reason why fluids are, why balls are floating is because the fluid exerts an upward force equal to the weight of the fluid displaced by the object. Kaya yung mga objects na less dense, they tend to go up. They tend to float. Bakit? Sige, I'll explain more later. Pero like, yung ball, di ba ano ba yung forces na nag-act sa ball? O sige, wait lang Let's, yun lang pala. Wait lang. So like, meron tayong weight fluid. Ayan o, look at this ball. Ayun, so bakit nagfo-float ang bola? Bakit nagfo-float ang bola? Kasi yung density ng bola is less dense than the density of water. Bakit? Wait lang Bali, naglagay tayo ng bola, may weight tayo ng object. It's M object G, pero yung fluid displaced by the object, ano siya? 'Di ba na-discuss natin kanina, ang weight is mass times gravity, density fluid volume times gravity. Okay. Kapag kapag less dense yung object, o sige, let's rewrite this in another way. Density object V object G. Ayan. Ayan. O sige, kapag less than yung density ng object na to, may free body diagram. Buoyant force. Yung tawag pala sa force na to is buoyant force. Yung pala yung tawag doon, no? If you've heard in Physics 1, yun ang buoyant force. Ito yung dinidiscuss natin ngayon. Buoyant force, tas weight ng object. Yun yung nag-a-act sa object. Okay, isipin nyo, PFVG VS raw object VG. Okay, kapag mas dense yung liquid, mas malaki yung magnitude nito, di ba? Mas malaki yung magnitude nito. So like, pataas siya. So net force goes up, kaya nagpa-float yung bola. Pag mas dense yung object kaysa sa liquid, sa fluid, bababa. Kasi yung dominant net force is this one. Ayan. Yun ang sinasabi ng Archimedes principle. That's why when you submerge a metal ball, it will sink to the ground. That's Archimedes principle yan. Okay, ito mag-problem solving na tayo. Yun lang siya. Yun lang yung gustong sabihin nun. 15 kilogram solid gold statue is raised from the sea bottom. What is the tension in the hoisting cable when the statue is at rest and completely underwater and at rest and completely out of the water? So, sige. Letter A. Letter A, ano yung mga force na nag-act? Ano yung mga force na nag-act? Statue, buoyant force, weight, plus buoyant force plus tension. Yan. Yan yung nag-act. Ngayon, alam niyo na dapat to. At rest siya and completely underwater. So, ang sum of forces along the y-axis equals to 0 equals to B plus T minus mg. Buoyant force, weight of the fluid displaced by the object is the buoyant force. So, rho gold, V gold, G plus tension minus mg, 15 times 9.8. Solve accordingly, you'll get na yung tension. Oops, may mali ako. Okay, let's be careful. Buoyant force, rho, seawater ba siya? Seawater. V gold, kasi yung volume ng gold, yun din na-displace na fluid by the object. G, T minus M gold, no? M gold. M gold G. Ano ba yung density ng seawater? 1.03 times 10 cube kilogram per meter cube. Yung volume, saan natin makukuha? Meron tayong mass ng statue, meron tayong density ng gold, di ba? So ano yung mass ng gold? 15.0 kg over density gold 9.3 times 10 to the kilogram meter cube G. Yan. Yan na. Paki-solve na lang. Is what you'll get. Ito raw yung buoyant force. Okay. Letter B. Letter B. Letter B, out of the water. Actually, same equation, no? Same equation. Actually. As in, papalitan mo lang to ng air. Pero actually, yung air kasi sobrang liit lang ng density niya. Di ba? 1.20 lang siya. Sobrang lapit niya sa 1. So actually, kahit ano lang, kahit ito lang yung gawin niyo for letter B, okay na. Simple physics. Diba, sa mga physics problems, you don't assume na may buoyant force, lalo na pag nasa air lang siya. Okay? Before we continue, do you get it? Gets ba yung way of thinking? Okay. Next, fluid mechanics, continuity equation. Last 2 chapters na to ng ng first half of the first quarter. Pero kasi yung isang first half, di ko na di-discuss yun. Kaya nyo na yun. Let's just focus on problems today. So, ito. Ngayon, dati, statics lang, di ba? Hindi gumagalaw yung fluid. Ngayon, try naman natin paano pag gumagalaw na. So, dito sa pag-aaral natin, we consider ideal fluids or fluids that are incompressible. Meaning, density cannot change, tsaka walang internal friction or yung viscosity na tinatawag. So, dahil alam nating the mass of a moving fluid doesn't change as it flows, it can lead to the continuity equation, which is a very important equation dito sa physics. Pero ba't naging ganyan? Ba't naging ganyan? Ba't naging ganyan? Ba't naging ganyan yan? So, sabihin natin na yung speed at this, let's concentrate on this figure. Let's see the speed. Kasi mag-iiba yan eh. Mag-iiba yung, pag nag-iba yung, okay, di ba, ano ba mas maganda i-explain to? The same fluid volume, dV, exceeds, kumbaga, kung ano man yung pumasok na fluid amount, yun din yung lalabas. Okay. So, isipin nyo, pag lumiit yung area, ano kailangan gawin ng fluid mo? Di ba dapat mas mabilis siyang lalabas? Kaya may continuity equation, guys. Mas mabilis siyang lalabas, no? Kaya nangyayari to. Okay. So, let's examine. No? At saka guys, kasi, bawal lumabas yung fluid dito. Bawal lumabas siya, walang butas. So, the fluid is forced to pass through here. Kailangan at a given time, at a given same amount of time, di ba, isipin nyo, same amount of time. Tingnan nyo tong element na to, tingnan nyo tong element na yan. The amount of water passing through them, or at least at any point, dapat pare-pareho. I hope you get that meaning. So now let's derive. So, merong velocity 1, merong change in time, yun yung length nito. Meron tayong cross-sectional area, E1, V1, dt. Kung ano man yung pumasok, yun din lalabas. So, same idea dito. Length times area, A2, V2, dt. Which leads to our continuity equation. Or, may kulang pa akong ginawa, sorry. Pero pareho lang yun. Di ba sabi, mass flowing in and out? Hindi kasi porket pareho sila ng volume na flow in and out, the same amount na yung lumalabas. So, always nice to examine mass. So, let's examine the mass. Ano ba yung mass? Mass times volume. So, volume times density. Yan. So, same fluid lang sila. Kaya ganyan. Cancel the same terms. Yan. Pero actually, ito, di ba nakuha natin kanina is PA1 V1 dt equals dV. Yung volume flow rate is dV divided by dt. How much volume is flowing per time? Ngayon, kung gusto nyo ng mass flow rate, ito gagawin natin. Okay? Yan. Okay. Tingin ko kaya nyo to, guys, eh. Sige nga, can you I'll give you 2 minutes, 3 minutes to try. Ito. After ito, last topic na. Yun, no? Tapos magsusolve tayo ng maraming problems. So, let's go. Ito nga, try natin. I want to see if you get what I've been talking about. Some things to note. Ang flow speed pala is ito, tong V. Yan ang flow speed. Okay. One thing you should note, ano to? What is this? 9.5 liters per second. Yan ang volume flow rate. Diba? Kitang-kita naman. dV over dt. Sige, 3 minutes. Gusto ko masagutan nyo to. If you need the relevant formula, ayan. O hindi yata kita. Wait lang. Ayusin ko nga yung quality nung... Shucks, naka-auto lang pala yung quality. Hindi siya naka-high quality. Yan, high quality na siguro yan. Yung sagot kaya sa number 1, pareho lang sa sagot sa number 2. Pa, that's the other thing to take note. One minute. Sige, 6 p.m. Ay, 5 p.m. dyan. Let's discuss. Oh, naka 1 hour na tayo. Okay. So, you're doing great. Konti na lang. Okay. Alam natin yung continuity equation, A1V1 equals A2V2. Ano pa yung isa nating nalaman? dV over dt equals dV over dt equals matawag doon. A1V1. Tsaka rho dV over dt equals rho A1V1. Pa isa nating alam. Mass volume, ay mass flow rate, volume flow rate, continuity equation. Okay, what's next? Ano yung given? Oh, dV over, wala tayong A1, A2, tsaka V1, V2 eh. So, ito na yung pwede natin gamitin. 850, 9.5 liters per second, A1, V1. Ano ba yung A1, V1? A1, V1 is 8 cm. So, 0.08 squared times pi times V1. Diameter yon. So, dapat 0.04. Equals to 1.9 meters per second. What's next? Mass flow rate. Mass flow rate. So, multiply ko lang yung ito sa dV over dt. 850 kilograms per meter cube times 9.5 times 10 to the negative 3 meter cube per second. You will get 8.1 kilogram per second. From the continuity equation, V2 equals A1 over A2. V1. Um, letter B pala to, no? Kasi meron na tayong A1, V1, A2, wala na tayo V2, no? So, is there another way to do this? Pwede mo rin gawin yung pwede mo rin gawin yung kanina, yung ginawa ko sa unang item, ito, pwede rin to eh. Why? Bakit pwedeng gawin yan? Bakit pwedeng gamitin to? Kasi, at any 2 points along the fluid, pareho lang. Equal mass flow and volume flow rate. Ang nalabas is 7.6 meters per second. Ano napansin nyo? Do you get why? Times 4. Bakit? Kasi yung area ng section 2 is 1/4 of the area. Hinaf yung radius eh. Diba? So tama lang na dapat bumilis ng times 4 yung rate dito sa second section. Before I continue, do you get it? Okay, sige, that's good, that's good. All right. Last item for today. Hindi para ay mag-solve tayo ng problems after. So, ito, Bernoulli's principle. Ito, familiar to. Kasi ano to eh, it's like the conservation of energy. Actually, doon siya nanggaling. Anyway, so, di ba according sa continuity equation yung kanina, kapag diliitan natin yung area, nagva-vary yung speed, no? Of fluid flow. Pressure can also do so. Kasi 'di ba kasi 'di ba nalaman natin kanina na pressure depends on depth. Tsaka ano na rin, dahil sa speed, no? Kapag mas mabilis yung speed, mas tumataas din yung pressure. So, nakakagawa tayo ng Bernoulli's equation, Bernoulli's principle. So, when an incompressible fluid flows, pakibasa na lang, its speed must change and so one element of fluid. Kasi kapag nag-flow ang isang fluid, may acceleration yan. No? If the tube is horizontal, the force that causes this acceleration has to be applied by the surrounding fluid. No? Kasi yun lang naman yung tutulak eh. Ano ba man tutulak sa fluid kung hindi fluid lang din? Yan. Pressure. Sige, paano natin i-derive? Use conservation of energy. Teka na nga. Okay. Apply the work energy theorem to the fluid. Paano yun? Paano natin gagawin yun? So, may stock sa messenger. Paano natin gagawin yun? Okay. Let's examine ito. Let's examine itong dalawa na to. Diba? As we have described kanina, yung DS, itong length na yan, V1 dt, diba? V1 dt. Pero actually, yun nga, pinangalan lang natin iba. Ngayon, ito, yung isa. Next, what's next? Ito, from A to B, C to D. Next. Ganun ulit, yung volume is equal to A1 ds1, A2 ds2. Diba? What's next? Let's compute the work done on the fluid. So, yung kung mapansin nyo, di ba nga siya? I mean, siya eh, from the atmosphere, open siya to the atmosphere. So, meron siyang force dito, meron siyang din siyang force dito. So, ang work, change in energy, is force times distance minus force times distance. No? Diba? Force times distance yan. Force times distance. Force times distance. Equals to P1 minus P2 times dV. Diba? Kasi, na-derive nating dV yung mga ito eh. No? Okay, malapit na guys. Malapit na. Hindi masyado importante ito eh, pero let's go. Mas, yan, work yan. Kinetic energy naman. Yung kinetic energy, yan yung kinetic energy. Oh, kinetic energy at the start equals to dk. Dapat dk eh. dk. 1/2 mv squared. 1/2 m 1/2 rho dv ay rho v squared, di ba? Rho a1 is 1 v1 squared. dk2 equals 1/2 rho a2 is 2 ds. Rho times v eh, di ba? v2 squared. So if we get it, all in all, dk equals 1/2 rho dv ng v2 squared minus v1 squared. What's next? Meron ding change in potential energy. Di ba ang change in potential energy is mgh, di ba? mgh kasi ano yan eh, umakyat from one height to another, right? mgh. Mass is rho dV G times Y2 minus Y1. Rho GH. Hindi na natin, wala na tayong paki sa yung pinagkaiba ng potential energy tsaka ito. Kasi we just look at the final and the initial state. Okay, now we continue everything, we compute everything. Diba, ito yung work kinetic energy principle. So, ipasok lang natin lahat. Cancel everything. Tapos na tayo. The work done on a unit volume of fluid by the surrounding fluid is equal to the sum of the changes in kinetic and potential energies per unit volume that occur during the flow. Ito yung tandaan nyo. Para siyang conservation of energy. Okay? Kasi ito last one. Sige, ako na lang muna magsasagot. Okay, let's go. Haba, no? Ako rin, nalilito rin ako. So, pasensya na. E1. Ito yung nakuha natin. Na equation. E1 plus rho gy1 plus 1/2 rho v1 squared. V2 plus rho gy2 plus 1/2 rho v2 squared. Ano kailangan natin? Find the flow speed and in the bathroom. So, ang given natin is yung mga nandito pa lang. Di ba? Ito lang yung meron tayo given. Diyan. Inlet pipe. V1 equals to V1 equals to 1.5, Y1 equals 0, syempre, di ba? Kasi sabihin natin yan yung 0, tapos dyan lang siya umakyat, di ba? Y1 equals 0, ano pa ba? V1, Y1, P1 equals to, as given, 4.0 times 10 to the negative 5. Anong hanap natin? Find the flow speed, pressure, and volume flow rate in the bathroom. Ito, ano raw to? Ano raw yung mga properties dyan? No? Syempre, para makuha yung pressure, kailangan mo ng para makuha yung pressure, kailangan mo itong gamitin. Pero, kailangan mo na natin makuha to. Paano makukuha yan? We need V2. How can we get V2? We have the continuity equation. Paki-compute na lang, ang makukuha nyo, kasi ito yung diameter ng una, ito yung diameter ng pangalawa. 1.0 cm, no? So, paki-compute na lang, you will get 6 meters per second. Tapos, substitute dito, sobrang haba na talaga, I can't write, sorry for that. You'll get P2 equals to tapos ano pala, let's summarize ano yung mga properties na meron dito sa bathroom. Para lang gets nyo what is in the problem. Diameter of the pipe, 1.0 cm, y2 equals 5. Ito kasi, y2 equals 5. P2, V2 unknown. Yun lang. Yun ang given sa'yo. So, P2 is 3.3 atmospheres. Substitute dito. I can't write everything, sorry. Volume flow rate in the bathroom. Madali na yan. Ano nga ulit yung volume flow rate? Continuity equation. Actually, kahit anong side yung gamitin mo, equal sa dV over dt. So, basically, i-plug in nyo lang yung nakuha nyo. So, kahit yung A1, V1, meron na kayo niyan. May volume flow rate na agad kayo. A2, V2, okay lang din. Ayan. That's all the concepts you need to learn for today. You get how to use the formulas? Do you get in general how to do it? Saan po pala nakuha yung P2 equals 3.3 ATM? Sabi ko nga kanina, Megan, di ba ang first step is to get V2. Bakit? Kailangan nating gamitin yung ito. This is Bernoulli's principle. Solve for ano? Bale, solve for P2. Ayan, solve for P2. Plug in all the values you got. Bale. Kasi meron ka na lahat yan eh. Diba? Yan. Substitute lang, tas solve. Okay? Yan. Okay na? Let's go to the next part of this day. Okay. Sige, let's start with number 1. Concept-wise, dali. Isang tingin lang, alam nyo na agad yung sagot. A, B, C, D. Dali. Madali lang to. A, B, C, D. Hindi. Ano ulit yung ano? Hindi rin. Hindi rin. Hindi. C. C, guys. C. Bakit? Buoyant force equals weight of the fluid displaced. Diba? Buoyant force equals weight of fluid displaced. Ano yung weight of fluid displaced? Saan equal yun? Raw fluid V object G. Ano sabi sa problem? Have the same volume. Yung def, walang ano yan, walang kinalaman yan. Ito, walang kinalaman yan. Yan, wala yan. No? O they using this, C dapat. C. Okay? C. Next, what if the shape of the wood makes it such that it has the same volume as iron but has air inside. Again, um, again, uh, hindi, kasi kahit papano, Jeremy, pag ginawa mo yan, ang mag-iiba is yung density ng object itself, no? Kahit ano mangyari, Jeremy, Kion, kahit ano man yung laman ng object mo, ang importante kung ano yung nadi-displace niya. You get what I mean? Yun lang. So, whatever's inside the object you have, kung ano man yung na-displace niya, that's the buoyant force. It depends on that, and that only. What happens if you have air inside? It just changes the density of your wood. Bababa yung density. Yun lang yun. Mas mabilis siya mag-float, something like that, no? Number 2, ito. What do you think? A, B, C, D. No. Oh, 30 seconds. Yes, tama. Sige, bakit D? Bakit D? Bakit D? Why D? Why D? Why D? Bakit D? Sige, bakit D? Ito mangyayari. Di ba? Pressure equals force is proportional to the surface area. No, not exactly. Pero ang pinaka-best answer is Pascal's principle. Bakit? Pero pwede rin sinabi mo, Jeremy. Pero ito kasi, pressure o not plus rho GH. You are sure na pare-pareho yung pressure, no? You're sure na pare-pareho yung pressure. At the bottom pala. So dahil pare-pareho yung pressure at the bottom, pare-pareho yung surface area at the base. Di ba? Ay, nakasulat yan. Force over area is the same, pressure is the same. Pare-pareho yung area. All three are equal. Yeah? Yan. Last one. Actually, skip natin yan. Okay. Sige. Ito. Classic problem. Letter A, what is the gauge pressure here? Diyan. Ano rin yung gauge pressure dyan? Letter B, calculate this. Teka, maghahanap ako ng density. Pero you can start na. Go ahead. Density of mercury is 13.6. Ito, 1,000. Okay. Ngayon, check natin. Okay. Kuha ko na. H na yun. Equal sa H no? Water. Okay, sige. Check ko lang if tama sagot ko. Dali lang to, I swear. I think it's easy. Clue. Kita niya to? Dapat. Yung pressure dito, by Pascal's principle, dapat equal siya sa pressure dito. Gawin niyo yung problem in terms of the sequence given to you. Kailangan niyo muna talaga to. Ano yung mga formulas na discuss natin? Siguro na relevant dito. P equals P naught plus rho GH. Pero, gauge pressure. So, dali. Ano na lang yan? Super giveaway. Bigyan ko pa kayo ng 4 minutes. Mm. Next clue. Hindi ko pa nako-compute eh. Wait lang. Sorry. Ah! Wait. 147,000? Can you check your units? Baka may hindi ka kinonvert. Baka may hindi ka kinonvert. Hindi mo kinonvert yung height to meters. Megan, check mo. Hindi mo yata kinonvert to meters yung height. Ah, yun. Okay. Good job. Ayan, sige. Kaya mo na yan. Kaya mo na yan, B. Good job. Sige, I'll give you until 6:40. Ay, magandang sagutan natin. Um, ah, dali. Basahin mo yung question ulit, Megan. Nandyan ka na. May, basahin mo ulit. Yan ba dapat or yung isa? Tama yung 1.10 na yan, pero yan ba dapat yung isagot mo? Dali. You're almost there. Yon. Good job. Sige, let's wait for one more minute. Ayos. Good job. Okay, game. Ganyan to guys. This is a classic question. Yung letter A, ano yung madaling compute? Siyempre ito, given na agad, oh. Diba? P minus P naught, gauge pressure, raw fluid, GH. Yan, di ba? Ano yun ang gawin natin? 1,000 times 9.8 times 0.15. Yan. What's next? Okay. Okay. Next. Okay. Calculate the vertical distance h from the top of the mercury in the right-hand arm of the tube to the top of the water in the left-hand arm. Ito raw. Ano raw to? Okay. Napansin niyo yung sinabi ko kanina? You create a line. Kasi yun lang yung ano eh. Ano ba? Yun lang yung interesting na i-examine, di ba? The pressure exerted at around the fluid is the same. Ano yung pinakamadaling tignan? Kung saan nag-i-intersect yung tubig tsaka yung mercury, kunin mo rin yung kapantay niya. Yun na. So, ito, pressure, water, equals P mercury dito. Gauge pressure. Or kahit yung absolute pressure. Pero wala tayong mapakin doon. So, meron na tayo, ito yung P water eh. P water, P mercury is rho GH. Diba? P minus P not equals rho GH. So, rho GH. Pero ano yung H? Ano yung H? 0.15 minus H. You will find from here that ito makukuha nyo in the end. Okay, yan. Do you guys get it? Do you guys get it? Do you guys get it? Nakuha ba? Sige. Alright. Let's go to the next one. Process muna natin yung given. A cubical block of wood 10 cm on a side floats at the interface between oil and water with its lower surface 1.5 cm daw to. The density of the oil is 790 kilograms per cubic meter. What is the gauge pressure at the upper surface of the block? What is the gauge pressure at the lower face of the block? What are the mass and density of the block? Sige, ano ba yung mga relevant equations? Gauge pressure, rho GH, di ba? Next, what else? What else? What else? Um, Archimedes principle, weight of displaced fluid, equals buoyant force. Ano pang alam natin? Yun lang. 'Di ba? At rest ito, pag floats at rest yan. So, we can do some free body diagrams. Yan. I'll leave it up to you to try first. Sige. I'll give you 15 minutes for this. Or 10. O sige. Clue. Ano yung height na to? By geometry, ano dapat? 1.5 cm din, right? O sige, pag uh,
mag-glue. Dito, ano yung, saan nagagaling yung pressure? Sa water lang ba or pati yung oil? Yun pa yung isa kong tanong sa inyo. Mhm. Ang hirap to ah. Sige, kaya. Okay, sige, sige. Ito muna. 7 minutes? You guys need help? Hindi eh. Ay, wait. Teka, check ko. P-oil. Ano ba yung P-oil? 790 times 9.8 times 0.15. Hindi eh. Hindi. Baka mali ka ng density. Density of oil is 790, no? Ah. Sige, try mo ulit. At least you get the ano, so good job. Good job. Sige, 2 minutes. O sige, 3 minutes pa. O 5 minutes pa. Sige, 5 minutes. 5 minutes. May tanong kayo, please ask me. Ay, sorry. Okay, 1 minute. Okay, tara, let's start. Okay, sige. Mm, sige. Oh, ayun pala, may nagsagot. Check dati yung sagot mo. Check dati. Check ko Hindi ko pa sinasagutan fully. Pero okay, let's start. Okay, letter A. Di ba hanggang dito lang yung oil? Oil? Yan lang yung force na meron siya, di ba? Walang nanggagaling dito. So, ang pressure, gauge pressure, P minus P naught equals rho GH, P gauge equals rho GH. Ano yung H na to? 1.5 cm. So, raw oil G 0.015 liters. Ang lalabas is 116.13 kilogram, hindi kilogram, Pascal. Pascal. Letter B. Oh, concept-wise, ano yung mga nag-exert ng pressure ng force dito? You have water, you have oil also. Right? So, i-combine mo yung pressure ng dalawa. Okay? Ano exactly yun? Eto, look. P gauge, P oil, plus P water. Ito, 1 plus 2. So, ano yung P oil? Raw oil G. Ano yung height? 10 cm. 0.1 meters plus P water 0.015 meters times G. Ang lalabas is 921.2. Lastly, mass and density of the black. Ito na yung pinakamahirap. Pero madali lang yan. Paano ba yun? Paano ba yun? May isip tayo ng magandang way. Pwede natin gawin yung mahabang way, pero ito yung naisip ko, guys. Tingnan nyo. Malupit to eh. Di ba? Weight displaced fluid equals buoyant force. Right? So, ano ba yung weight ng displaced fluid? Volume of the cube. So, bale, volume of the cube. Bale, ano? Mass fluid raw fluid V cube G. Gawa tayo free body diagram. Dalawa yung buoyant force dyan. B oil plus B water. Yung pababa, weight object. Weight wood. Yun yung kailangan natin. Pero guys, actually, merong shortcut dito. Do you know how? Itong water, ano siya? Nasaan na yun? Itong oil, nag-exert siya ng force pababa. Itong water, no, actually, mas magandang tignan. Like, from the top, merong force. From the bottom, merong force. Right? Yun yung buoyant force. Yun yung buoyant force, actually. Pero para hindi tayo malito, sige. Cancel. Ano tong M wood? Density ng wood, volume ng wood. 'Di ba? Ano pa pwede natin tignan? That's all? Sige, let's start. 790 times V oil. Ito, ano yung volume nito? 0.1 squared times 0.85. Ay, 0.085. Plus 1,000 times 0.1 squared times 0.015 equals to density wood, V wood, 0.1 meter cube. Solve. Ang sagot, bakit ganito? Dahil lang guys ha. Ba't mali? 115 kilos? Hindi 115 kilos eh. Less than 1 kilo dapat yung sagot. Cube. Ayun! I found it. Ang sagot is 821.5 kilogram per cubic meter. And yung mass is rho times V. So multiply by 0.1 cube, you will get nakuha ba? Nakuha ba? Nakuha ba? Nakuha yung application of concepts? Do you get? Do you get it? Yes, no, maybe. Bakit po pataas yung B oil? Bakit pataas yung B oil? Ah, hindi, um, kasi ano, 'di ba? Ang buoyant force always acts opposite the paano ba? Buoyant force always acts opposite the kung nasaan yung object. So kung nilulubog mo siya, nasa baba siya, ang tendency parati ng buoyant force is to keep it away from the fluid, no? Kaya siya pataas. That's the definition of buoyant force. Okay? Yun. All right. Sige, ito. Medyo mahirap to. Pero wait lang may titignan lang ako. Titignan ko yung sagot. If tama ako. Figure. Pero go, you can start. I will discuss the problem in a while. Hirap nito Sige, go. Mm. Shucks, hirap nito. Pero sige, let's go. This one is Bernoulli's principle. Bakit? Yung, di ba meron kang initial, something dito? Kung ano man siya dyan, dapat pareho. Right? Naalala yung Bernoulli's principle? Actually, sige, I can just discuss. I don't mind. The valve is opened. What is the maximum height above point B attained by the water stream coming out from the right side of the tank? Assume H equals 10, L equals 2, and theta equals 30. Assume A is very large. Bakit inassume na ganon? Bakit inassume na very large? Para ano? Para hindi halata na, kasi kapag kumonti yung volume niyan, parang infinite source. Do you get what I mean? Para pag kumonti yung volume, pag may lumabas dito, hindi na babawasan at all yung volume dito. So sige, let's start. Bernoulli's principle daw. Paano? PA plus, ito, let's compare at this. Let's compare at these 2 points, no? Let's compare at these 2 points. Ito, wala tayong paki dyan. PA plus rho GH plus 1/2 rho VA squared equals PB plus, ano to? Ano to height na to? Rho G L sin theta. Diba? Plus 1/2 rho VB squared. Yan, diba? Okay, what's next? Also, dahil sobrang laki nga nung ano dito, sobrang laki ng cross-sectional area, wala na tayong paki dito. No? Wala na yan. Kasi, dahil nga sobrang laki ng cross-sectional area, parang hindi na gumagalaw halos yung A. Parang hindi nagfo-flow. Kaya ganyan. Next. Ano yung pressure dito? Ano yung pressure dyan? Or rather, ano yung pressure dito? Ano yung pressure dyan? Yun yung PA tsaka PB. Ano yung pressure dyan? Kumbaga, di ba yung total pressure is the pressure here? Yung total pressure at this point is the pressure here at the surface plus rho GH, di ba? Wala. Wala na yan. Bakit? Kasi ano yan eh, equal atmospheric pressure pareho. Right? Atmospheric pressure siya pareho. So, what do we do next? Solve. Hindi ako magpa-plug in ako, no? Pag sinolve natin yung equation, we'll get this. Ito, yan. Ngayon, mag-kinematics tayo to get the maximum point. Paano yun? Diba projectile motion yan? Dali lang yan. Pag projectile motion with a flat surface, edi ang max height equals to VIY VB, bali VB sin theta squared over 2G. Tapos na tayo. Substitute natin lahat yan. If we substitute all of this, we will get Y max equals to 2.25 meters. Medyo mahirap pa rin napili kong problem. I'm sorry for that. Pero it looks simple, right? Do you get it? Or no? Hanap tayo ng isa pa. Bernoulli's equation. Ano kaya maganda? O sige, ito. Kaya, Let's try this. Mahirap na naman 'to, eh. Open tank hose. Hirap 'to, pero sige, let's go. Um, lipat tayo ng screen, ha. Last problem na 'to. Continuity equation naman yung pag-aaralan natin. Last problem na 'to for the week. Yung next meeting para natin, it's either hindi bukas, no? I have to do something tomorrow. Ito. You see this? Paki-screenshot yung problem. Paki-screenshot para naintindihan what I'll do. Yan na, paki-screenshot. Okay, yan, screenshot na ba? Okay. So game, let's answer this together. Okay, let's answer this together. Ito, continuity equation. Okay. Ito. Ito, di ba? Okay. Napansin niyo bakit yung tubig kapag pababa siya na pababa? Paliit, no? Kasi kapag habang bumababa yung tubig, may gravity. So, bumibilis yung flow ng tubig. So, liliit yung area na sakop niya. Alright? So, ngayon, meron daw height of separation na 45 millimeters. What's the volume flow rate from the top? Okay, paano kaya yan? So, what do we know? We know that A naught, V naught equals AV equals dV over dt. Number 2, may gravity, di ba? Paano natin i-account yun? Kinematics tayo. From this point to this point, 45 millimeters. Starting from V naught equals to, teka lang, may titignan lang ako. Ito yung VF squared. Itong V squared equals V naught squared plus 2GH, di ba? Naalala to? What's next? Okay. Ngayon, kapag square natin to, A naught squared V naught squared equals A squared V squared equals dV over dt squared. No? What's next? Ayan, substitute natin dito. A naught squared V naught squared equals A squared V naught squared plus 2A squared GH. O, tapos na tayo. Bakit? V naught squared times A naught squared minus A squared equals 2A squared GH. V naught squared equals 2A squared GH over A naught squared minus A squared. V naught equals to, yan, square root niyan. Tapos na. A naught V naught equals A naught square root of 2A squared GH over A naught squared minus A squared. Plug in all the values. Ano makakuha natin? Square root ng 2 times A naught. Ano ba yung A naught? 1.2 times square root of, di natin kailangan mag-convert, 2 times 0.35 squared times 9.8 times times 4.5 cm all over A naught squared, so 1.2 squared minus 0.35 squared. We will get 98. Ay, wait may mali. 9.8 meters, 980. We will get 34.364 cm cube per second. Ayan. Do you guys have any questions? Do you guys have any questions? Ano naman so far? Okay. So, ayan. Yan, kasi 7:30 na. I guess we can call it a day. What do you guys think? Yan, marami tayong ginawa. Medyo mahirap, no? Medyo mahirap yung mga pinili kong problems. I'm sorry for that. But it's interesting kasi. And they're the best way to apply. Anyway, if we're done, I guess let's call it a day. Are you okay with it? Okay naman ba yung lesson today? Or mahirap ba? What do you guys think? Anything I should improve on? Pero okay naman. Sige, ganun talaga, no? Nasa P6 na tayo eh. Ganun talaga. Okay ako during daming concepts. Ganun talaga. Kasi nga, we have less meetings than last year. Last year kasi nasa-flesh out ko talaga. Kasi no more time for that. So, kinukuha ko yung most important, no? Yung next natin is math limits. So, yun, sobrang dami na naman nun. So, be ready na naman. Anong core ko ng SYP? Physics core, level 2. So, kaya alala ko pa yung mga to. Kaya, physics core ako. Physics core. Tapos, nung grade 11, engineering. Nung grade 12, Comsci, level 2 both years. Yun, what I did. Naayos ko na yung Google Classroom. I don't know if nakita nyo, pero yes. Ayun. Well, if you have no any other questions, well, see you on Friday siguro. I will finalize the schedule. Definitely hindi kayo bukas. Kasi hindi ko pa tapos yung para sa inyo. Okay? Yun na. Yeah, sure. No problem. Thank you rin. I hope you're having a great yeah. Ingat. Hmm.